Welcome back, Geometry. Hope you guys had a great break, a chance to relax a little bit. As we come back, we got 2 weeks left in the semester, so let's make sure to finish strong. If you have any missing work, there's still time, but you got to get it in soon, or else it'll be too late. Okay. So, just to remind us where we were at, before break, we had talked about 3 types of transformations. Translation, where the shape slides in one direction. Okay. A reflection, where it kind of flips over a line of reflection, and a rotation, where it turns around some central point. Now today we're going to talk about one, and the difference with this one is the shape will change size. So today's word is dilation. Now some of you maybe have gone to the eye doctor, got your eyes dilated. It's when the pupils get like really big so they can see them better. Then you have to wear those glasses when you leave. Okay, so dilation is a transformation in which a figure is enlarged. Now, it's not just getting bigger, though. It also could be reduced. And the key is it has to be around a central point uniformly. Now, what that means, uniformly, think of like a uniform, means everyone's wearing the same thing. So uniformly means it's consistent throughout the shape. The shape will still have the same ratio to its side lengths. It'll just be bigger or smaller. Okay. And the way we find out what this ratio is compared to the original, this ratio of the dilation is known as our scale factor. So make sure you get these 2 words down, scale factor and then dilation. If you want, you can take a screenshot here or pause the video if you need to. So while you're working on that, take a look at this. We've got 3 different pictures here. We don't know which of the following represents a dilation. Okay, so we know dilation means the size of the shape changes. So hopefully you guys know this has to be the first one. The skateboard has to be our dilation. Because depending on which one, if this was the pre-image, then it is enlarged. If this is the pre-image over here, the big one, then it was reduced in size. Okay? Now, think for a minute about the ring. And hopefully that ring is, you can see, is an example of rotation as I spun it. And our last one, the skates, would be an example of a translation. All right, so now as we go on to this, we're going to graph our dilation. So it says draw the dilation of triangle PZG. So PZG is here. Use the origin as the center and n equals 2. Now this n equals 2, that is our scale factor. So by your scale factor, you might want to write n equals. If you ever see that, that's what that means. Okay. Now, sometimes it'll just say the scale factor is 2. The other way here, you see the rule d2 of xy equals 2x 2y. Because the dilation was by 2, we multiply that with each of those. So 2 times x is 2x, 2 times y is 2y. Now, just to keep in mind, if the dilation, if the scale factor is bigger than 1, so you might want to, or you probably want to write this down. So if n is greater than 1, then that means it's going to be enlargement. Okay, we're getting bigger. Now on the back, we're going to do one if n is less than 1. That is an example of a reduction, meaning it will get smaller in size. Now, in order to do this, the first thing we need to do is establish what are z, g, and p. What is our pre-images points? So z, g, p, we can write those down. Z compared to the origin is left 3, up 1, so negative 3, 1. G does not move left or right, so we'll put a 0. It's down 2, so negative 2. And finally, P is positive 2, negative 1. Okay, so those are my original points now for my pre-image. Now to get my image, with our scale factor here of 2, we just multiply each of these by 2. So it's pretty simple. Z prime becomes negative 6, 2. G prime Now on this one we have a 0. So if it's a 0, 0 times 2 is still going to be 0. 2 times negative 2 gives us negative 4. And then finally p prime 2, negative 1. If we multiply both those by 2, we'll get to 4, negative 2. Now, if we are graphing it, which in this case we are supposed to draw the dilation. So I think on your It's Learning homework, that would be all you'd have to do is fill in those 3. For this, though, we want to graph it. So negative 6, 2, 0, negative 4 here, and 4, negative 2. And as you can see, it was stretched. It's now bigger. Okay, so obviously my line a little off there, but a little curvy. But overall, it's a good representation of what happened. It's an enlargement because n was greater than 1. So if we look at this next one, it says draw the dilation of triangle PZG. So once again, we're using triangle PZG. This time n is equal to 1/2. So on this last one, we said it was an enlargement. On this one, before we even solve it, we should know, since n is 1/2, that's less than 1, we know this will be a reduction. It will get smaller in size. So what we first need to do, once again, is find what Z, P, so Z, P, and G. What are those coordinates? So if we look here at Z, it's left 1, 2, 3, 4, 5, 6. Up 1, 2, 3, 4, 5, 6. Okay, so negative 6, 6. P is at 1, 2, 3, 4, and down 2. So 4, negative 2. And our final one, G, is left 4 and down 6 also. So that'd be negative 4, negative 6. Now, if we have a scale factor of 1/2, all we have to do once again is multiply by 1/2. Or if it's easier for you to think about it like this, multiplying by 1/2 is the same as dividing by 2. So Z prime becomes negative 3, 3. P prime becomes 2, negative 1. And G prime will become negative 2, negative 3. So negative 2, negative 3, that's where G prime will end up. P prime we said was 2, negative 1. And Z prime, 1, 2, 3. It's right there. We connect our dots, and as you can see, this triangle is clearly smaller as it has reduced in size. It was a reduction. Okay, just about done. Let's do one more here. Once again, ZGP. This time, the scale factor here, n equals 3. So hopefully you already know if it's 3, this is going to be an enlargement. It will get bigger. All right, so if we go ahead and start by writing what Z, G, and P are. So Z is at, let's see, it looks like 0, 3. G is at negative 2, negative 3. And P is at 2, negative 3. All right, all we have to do now is find what Z prime, G prime, and P prime will be. So we multiply by 3 on both of those. We'll get 0, 9, negative 6, negative 9, and finally 6, negative 9. So 0, 9, 1, 2, 3, 4, 5, 6. Up here. Okay, then let's see. So G prime is at negative 6. and down 1, 2, 3, 4, 5, 6, 7, 8, 9. And then P prime is the same except at positive 6. So we label those and we're almost done. All right, and there we go. So make sure you get NIDS Learning and complete this assignment. It's just a few of these. You're going to fill in the coordinates. Very simple, should not take you too long. If you have any questions, please reach out. Hope you guys have a great day.